Hello and welcome to this another video. So our topic for today is conic sections, focusing on ellipse. Okay, so let's define what is an ellipse. So an ellipse is the set of all points P in a plane in such a way that the sum of its distances from two fixed points on the same plane is constant. These fixed points are called foci, plural of the focus, and the constant sum is also equal to the length of the major axis of the ellipse. So later we will discuss more about that. Okay, so we have here an illustration of the different parts of the ellipse. Okay, so we have the focus, the center, the vertex, and the co-vertex. We also have the minor axis and the major axis. Another part is the latus rectum. Okay, in this figure number 4, it means that the distance from the focus 1 to the point on the ellipse and focus 2 to the point on the ellipse, if we are going to get their sum, this is just equal to the distance from the vertex of the ellipse of the major axis. So let's have this short discussion. So we have center. So we have the center here. So the center of the ellipse has coordinate hk or 0, 0 if it is in the origin. The intersection between the major and the minor axis is also called the center. The foci or the focus is singular. The foci are two fixed points inside the ellipse which are equidistant from the center and lays along the major axis. Okay, so the foci, we can locate the foci along the major axis. For any point P on the ellipse, the sum of its distance from the foci is equal to the length of the major axis. So it means that the sum of this one and of this one is just equal to the length of the major axis. Vertices. The vertices are points on the ellipse collinear with the center and foci. So these are our vertices. And another one. A vertex is the end point of the major axis and is a units away from the center. So it is a units away from the center. So this distance from the center to the vertex is a units away. Thus, the segment from one vertex to the other is 2a. So therefore, from vertex to another vertex, this is just equal to 2a. Co-vertices. Okay, so the endpoints of the minor axis perpendicular to the major axis. So these are the co-vertices. So it is located in the minor axis. The length of the segment from the two vertices is 2b. So this is 2b. So from center to the co-vertex is just b. Okay, latus rectum. The chord that passes through a focus and is perpendicular to the major axis. So for example, in this figure number 3, the latus rectum is perpendicular to the major axis and is passing through the focus. So let's go to transforming general form to standard form of equation of ellipse. So we have here our standard form. We have the square of x minus h over a squared plus the square of y minus k over b squared is equal to 1. So example, we have 9x squared plus 16y squared minus 126x plus 64y minus 71 equals 0. So first is we are going to regroup same terms or similar terms. So those terms having the same variables. So for this case, we have 9x squared minus 126x plus 16y squared plus 64y equals 71. So we added 71 both sides of the equation. And then we factor out the common in each of the groups. And we allotted a space after this one for the next step. So after factoring, we are going to complete the square in this trinomial. So how are we going to complete? So we just have to divide the middle term by 2 and then square it. So negative 14 divided by 2 is negative 7. Then square of it is 49. And then we added the same quantity to the right side. For this term, we have 4 divided by 2 is 2, squared is 4. So we add also the same amount or the same quantity to the right side. So 16 times 4, 16 times 4. Next, express that as the perfect square trinomial into the square of binomial. So in this case, we have x minus 7, square of x minus 7. And in this case, we have square of y plus 2. We divide both sides by 576. So we just simplified the numbers on the right side. Then divide both sides by 576. And then we get the square of x minus 7 divided by 64 plus the square of y plus 2 over 36 is equal to 1. So this is now in standard form. Okay, so before we proceed to the next topic, so I have here an illustration of an ellipse. So remember that 2a is the distance between the vertices of the major axis. So in this illustration, our major axis lies on the horizontal, or the direction of our major axis is horizontal. So from V1 to V2. And 2b is the distance between the vertices of the minor axis. So our minor axis is from W1 to W2. And 2c is the distance between the two foci. So we have from foci 1 to foci 2 is our 2c. And if we are going to divide that one, that is the distance from the center to the foci. So that is our c. So important formula. So we have b squared is equal to a squared minus c squared. And the standard equation center at hk. So we have x, the square of x minus h over 2 over a squared plus the square of y minus k over b squared is equal to 1 for horizontal major axis. So this part is bigger than this part. And for vertical major axis, so we have x, the square of x minus h over b squared plus y minus k, the square of y minus k over a squared is equal to 1. So this is our equation for vertical major axis. So let's try to solve to find the standard equation of ellipse given the foci and the length of the major axis. Okay, so foci is foci are negative 3, 0 and 3, 0, and the sum of the distances of any point on it to its foci is 10. So our solution, let's identify first the direction of the major axis. So in this case, we have the major axis on the horizontal major axis. So since, how are we going to identify? Based on our foci, the unchanging or the constant in our foci is 0, or the y component. So it means that our x is changing. So that is our horizontal major axis. So if x is changing, So it means horizontal. If y is changing, that is vertical. So we have our major, the length of the major axis is 2a is equal to 10. So our a is equal to 5, then therefore a squared is equal to 25. And 2c. So where did we get our 2c? That is the distance between two foci. So we have 2c is equal to 6. So from the from negative 3 to 3 is 6. So c is equal to 3 and c squared is equal to 9. So b squared equals a squared minus c squared. So we have 25 minus 9 and b squared is equal to 16. Now we can have our center at 0, 0. So therefore, using the standard formula, we have x minus 0 or our h 0 over a squared. So a squared for horizontal major axis. Okay, so if x is changing, so that is our indicator that it is our major axis. And then y minus 0 square over 16 is equal to 1. So this simplifying, we have x squared over 25 plus y squared over 16 is equal to 1. So this is our standard equation of ellipse. Next, determine the standard equation of ellipse given the foci and the length of the major axis. So we have here a foci is 3, 8 and 3, negative 6. And the sum of the distances of any point on its foci is 18. Okay, so solution, direction of the major axis. So here, our foci is, the x component of our foci is constant or not changing. So therefore, this is vertical major axis. Okay, so our 2a or the distance of our the major axis, the length of our major axis 2a is equal to 18. So that is from the given foci. Then a is equal to 9, then a squared is equal to 81. And for our c, 2c, that is the distance between the foci, which is equal to 14. So 8 plus, from 8 to negative 6, that is 14 units. And then c is equal to 7 and c squared is equal to 49. So b squared is equal to a squared minus c squared. So b squared is 81 minus 49, that is equal to 32. Now our center is just between the two foci. Okay, between two foci. So you are going to use the midpoint formula to be able to get the center. Okay, so substituting the values, we have x minus 3 coming from the center squared over 32. 32 is, since our major axis is vertical and the y part of our foci is changing, so therefore this is our minor axis and the major axis is 81 or falls on the y component. Okay, so y minus square of y minus 1 over 81 is equal to 1. Okay, so let's look at the graph. Okay, so this is our center 3, 1 and our foci 3, 8 and 3, negative 6. So this is our equation. Next, we have to determine the standard equation of ellipse given the following. So we have the foci and the vertices. Okay, for solution, so the first, get the direction of the major axis. For this case, we have horizontal major axis. Why horizontal? Because our y component is constant and our x component is changing. Okay, so we have a horizontal major axis. So we have our 2a. 2a is the distance between the vertices of our ellipse. So we have from negative 8 to 8 is just 16. So a is equal to 8 and a squared is equal to 64. And 2c is the distance between the two foci. So we have 2c is equal to 10. So from negative 5 to 5. And so we have c is equal to 5, c squared is equal to 25. So we have b squared is equal to 64 minus 25, that is equal to 39. So the center is at the origin. So therefore, we have the square of x minus 0 over 64. So since we have a horizontal major axis, so this part should be greater than the other. Okay, so we have plus y square of y minus 1 over 39 is equal to 1. So simplifying, we get x squared over 64 plus y squared over 39 is equal to 1. And let's look at the graph. So horizontal major axis, so mas malapad dito compared dito. And our focus or the foci are negative 5, 0 and 5, 0 in our center. Next, determine the standard equation of ellipse given the following. So we have another example of foci and vertices. The solution, again, direction of the major axis is vertical. Why vertical? Because the y component of our foci and the vertices are changing. Okay, so we have the distance between the two vertices is 16. So divided by 2, we have a equals 8, 8 squared equals 64. And the distance between the two foci is 10. So c is equal to 5 and c squared is equal to 25. So b squared is equal to 64 minus 25. So b squared is equal to 39. Our center can be obtained by getting the midpoint of the two vertices or the two foci. So whichever points we'll use, it's up to you. So the center is can be obtained by getting the midpoint. So substituting the values in our general formula or our standard formula. So we have x minus the square of x minus 2 over 39 plus the square of y minus 3 over 64 is equal to 1. So we have a vertical major axis, so we put the bigger number over dy. So let's have a graph. Okay, so we have 211 and 28. We have 2, negative 2 and 2, 5. Okay, so determine the standard equation of ellipse given a point and vertices. So we have a point and vertices. The solution, so determine again the direction of the major axis. So looking at our vertices, we have a constant x component of our point. So therefore, we have a vertical direction of the major axis. So our 2a is equal to 10. So where did we get our 2a? So we get the distance from negative 5 to 5. So that is 10. So a is equal to 5, a squared is equal to 25. And the center is at the origin. So solve for b. So for this case, the given are point and vertices, we need to solve for b. Okay, so we have to use the formula x and the square of x minus h over b squared plus the square of y minus k over a squared is equal to 1 since we have a vertical major axis. So substituting the values, we have 4 minus 0 square over b squared plus the square of 2 minus 0 over 25 equals 1. So we have 4 squared is 16 over b squared 2 squared is 4 over 25 is equal to 1. Then cross multiply, we have 16 times 25 plus 4 times b squared is equal to the product of this one, then cross multiply. So we have 25b squared. So simplifying, 400 is equal to 25b squared minus 4b squared is equal to 21b squared. So we have 400 over 21 is equal to b squared. So we have to substitute the values. Okay, so we have x minus 0 squared over 400 over 21 plus square of y minus 0 over 25 equals 1. So simplifying, we have to get the reciprocal of the denominator. So we have 21x squared over 400 plus y squared over 25 equals 1. So let's look at the graph. So given the point and the vertices and vertical axis. Okay, so next we have to determine the standard equation of ellipse given the following. So we have center at 4, 3 and the length of the horizontal measure is 10 and the minor axis is 5. So solution, we need to get the direction of the major axis, which is already given in the problem, which is horizontal. And so we solve for the length of the major axis, which is 10. So a is equal to 5 and a squared is equal to 25. And the length of the minor axis is 5. So we have b is equal to 5 over 2 and b squared is equal to 25 over 4. So we have to plug in the values in our standard form of equation. So we have horizontal major axis, so the bigger number should be written below the x part of our equation. So we have square of x minus 4 over 25 plus square of y minus 3 over 25 over 4 equals 1. So simplifying, we have to take the reciprocal of our denominator, so it becomes 4 times the square of y minus 3 over 25. Looking at our graph, okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a distance of 10 units horizontally on our major axis. So this is our equation. So thank you for watching, and please like this video if you learned something, and don't forget to subscribe.